Topic evaporation. Topic evaporation. Evaporation. This evaporation is the chemical operation in which weak liquor is converted to thick liquor. Weak liquor is converted to thick liquor. So just I explain you with respect to one simple diagram. Here, suppose here we have this sugar solution. In beaker, we have taken sugar solution. This is our sugar. So this sugar solution that contains sugar molecule and water molecule. And this is sugar is dissolved in this water. So water is the solvent here and sugar is the solvent. So when we heat this particular sugar solution, what happens? Only water molecules that gets vaporized. Only water molecules that gets vaporized and that is removed. So here water molecule transfer from liquid phase to the vapor phase. So here water molecule that is removed, that is vaporized. And by which the concentration of sugar in the solution increases. That means, suppose here we have in the beginning 10 gram sugar and 90 gram water. Suppose here we have 10 gram sugar and 90 gram water. That is the solvent here. Water is the solvent. When we heat this sugar, when we heat this sugar solution, what happens? Out of this 90 gram of solvent, certain part of this water that gets vaporized and that is removed. And due to that, what happens? The concentration of this weak liquor increases. So initially, suppose it is 10%, that 10% that gets converted to 20%, 30%, depending upon how much water vaporized. So here, for this evaporation, the input to the evaporator or input to the evaporation operation is weak liquor that contains relatively less amount of solute. Okay, and you get output as thick liquor. The percentage of solute in thick liquor will be comparatively more with respect to weak liquor because certain part of the solvent present in the weak liquor that gets vaporized. So input to this evaporator is weak liquor, or input to this evaporation is weak liquor, while you get two output, one is the thick liquor and second one is the vapor. And this you get vapor from the top of the evaporator, while from water you get thick liquor. So how you define evaporation? Evaporation operation is defined as operation in which weak liquor converted to thick liquor. By vaporization. Now coming to the block diagram of this operation. Here we have this block diagram in this block diagram, A stands for solvent, A stands for solute. In this block diagram, A stands for solute, that is sugar, and B stands for solvent, that is water. Okay, so A symbol is used for solute, that is sugar, and B symbol is used for solvent, that is water. And the equipment in which this evaporation takes place, that is called evaporator. And to this evaporator, input is weak liquor, and you get two output from this evaporator. From the top, vapor is removed, and from bottom, heat liquor is removed. Heat liquor is removed. So, input to this evaporator is weak liquor, which is given by W, and that weak liquor contains certain fraction of solute and certain fraction of solvent. So XAW means what? X means fraction, A means solute, and W means weak liquor. So XAW means fraction of solute in weak liquor, that is XAW, and XBW means what? Fraction of solvent in weak liquor. Okay, so that is given to the evaporator. And evaporator, what happens? Certain part of the solvent present in weak liquor is vaporized, and for this vaporization, steam is supplied to the evaporator. So with the help of steam energy, certain part of the solvent that gets vaporized and it is removed from the top of the evaporator. So when certain part of this vapor is removed, remaining whatever you get from the bottom of this evaporator, that is called thick liquor, and this thick liquor is given by symbol here T. Okay, and fraction of solute in the thick liquor is given by XAT. X stands for fraction, A stands for solute, T stands for thick liquor, and XBT means what? Fraction of solvent in thick liquor. Okay, so in thick liquor you get solute plus solvent. In weak liquor, solute plus solvent is there. While from the top of the evaporator, vapor is removed, and this vapor, that is nothing but only certain part of the solvent only. So here if you just write down XAV, that is fraction of solute in vapor will be 0, because all solute, whatever present in the weak liquor, you get all solute in thick liquor. While certain part of the solvent that gets vaporized, and therefore you get solvent in vapor also, and you get solvent in thick liquor also. And therefore when we talk about the vapor composition, here XAV, that means fraction of solute in vapor will be 0, while fraction of solvent in vapor phase will be 100%, that is 1. Okay, so with help of this material balance equation and these symbols, we will write down the equation, material balance equation. So which is our first material balance equation? Our first material balance equation, that is TMB. TMB means total material balance. So when you see this block diagram, there is only one input, and that only one input is weak liquor, and there are two outputs, one is vapor and second one is the thick liquor. Okay, so we get this first material balance equation, that is total material balance equation. W is equal to V plus T. Okay. Now we go for second material balance equation, in which we take the material balance of solute. And the solute is given by symbol A. Okay, and just I explain you that whatever solute in weak liquor, all solute you get in the thick liquor, and in the vapor phase, solute is 0. So solute in weak liquor, that is equal to solute in thick liquor, that is our second material balance equation. And here we get this second material balance equation in symbol. W will be the amount of weak liquor and XAW will be the fraction of solute in weak liquor. So this gives total amount of solution weak liquor, that is equal to total amount of solution thick liquor. And this solution thick liquor is given by this formula. T is the total amount of thick liquor and XAT. XAT means what? Fraction of solution thick liquor. Okay, so we get these two equations, total material balance equation and solid balance. With the help of these two equations, we can solve unknown parameter concerned to this particular operation. Unknown parameter concerned to this particular operation.